Welcome to this video tutorial which focuses on using Google Spreadsheet to graph independent and dependent variable for middle and high school level labs. I will post the Google Spreadsheet document in the description below so you would have the ability to follow along. Let's do this. In this lab, the light source was moved different distances away from a plant and the volume of gas that was produced due to photosynthesis was collected. We can see that at closer distances, the volume of the gas that was collected was a little bit larger, and as the distance got larger and larger, the amount of gas that was collected actually reduced significantly. Here we have collected the data for the volume multiple times, so for about 4 trials to reduce the random uncertainties, and now it is time to plot the data. Before graphing, I want to make sure that you always check for your uncertainties. Here we can see that the volume of gas is given at an uncertainty of 0.5 milliliter, meaning that every time we collected the data, there was that much uncertainty. And when we record our data, the number of decimal places that we have must match the number of decimal places in our uncertainty, and they do match for most cases. Here we have 1 decimal place, 1 decimal, 1 decimal, 1 decimal. This one doesn't have 1 decimal, and there's a few that don't. So in order to fix that, I'm going to select all my values here. I know that when I was collecting each individual set of data, the uncertainty was to 1 decimal place. And there's a button right here which can change the amount of decimal places, and I'm just going to increase it to 1 so that it matches this one. We can see that for distance, the uncertainty was 2, and that has no decimal places, and all of our distances have no decimal places, so those match pretty well. I also want to quickly walk you through on how I did this table. So if you're ever having any problem, you can kind of get that. So here I have distance, which is my independent variable with uncertainty of 2 centimeters. So I'm just going to copy that. Basically what I've done is I have found the plus and minus sign from online, and I just added that in, and this is showing that I'm measuring the distance with this much uncertainty. The values that I have chosen for my distance for 20, 40, 60, 80, and 100. So those are my distances, and I've done my tests for 4 trials. So I'll write them as trial 1, trial 2, trial 3, and trial 4. And what I've collected on the top is volume, and what I'm going to do is I'm going to select these and I'm going to merge them, merge cells. I'm going to write volume of gas plus or minus. I'm just going to click here, copy, and you can do the same from online, 0.5 milliliters. And then I just write my data. So I'm not going to rewrite them again. I'm just going to copy them down. And once I've done all of that, in order to shape these and make them look good, I'm going to select all of them, and I'm going to go right here to horizontal alignment and make sure that everything is horizontally aligned. And I'm going to go to vertically align and make sure everything is also vertically aligned. It's kind of weird that the distance here is actually before that I'll go select everything, go to borders and create some borders. And I am also going to color my independent and dependent variables using a gray color. You can change it to any color really. And I'm just going to change it to this. And in order to bold my data as well, I want my distance and my volume to be bolded. And I press Control B, it's Command B on the Mac, and that kind of bolds everything. Now, this is kind of weird having the distance like this with some empty cell over there. So I'm going to click both of these and merge them, and now it looks pretty nice. And in this one, I should have vertically aligned. So now this is how I got to what I got. Now that you know how we can do the graph, I'm just going to remove this by right-clicking and deleting it. And now we have our independent variable, and we have multiple data that was collected for our dependent variable. And we don't want to show all of these values when we're graphing. So what we do is we find the center and the spread. There are many different ways of doing this, and because there's so many different ways, we need to show exactly what we are doing for our calculations. So within your lab, you need to show some sample calculations. I'm going to copy this set of data. So I'm going to right click and copy. I'm going to go to this document here, and I'm just going to paste it just so that I have it for my reference. And link to the spreadsheet is fine. And here, the next step is to write some sample calculations. I'm going to go to normal text, and you get to choose which independent variable you want to do your sample calculations for. You can do it for the 20, 40, 60, 80, or 100. It doesn't really matter. I'll usually like to use something in the middle, so when I'm using the equations later inside of the Google spreadsheet, it doesn't actually I can actually check my work. It usually helps. So what I'll write here is that sample calculation for distance of 60 plus or minus. For the plus or minus, I'm just going to copy this plus or minus 2 centimeters, and I'll leave some space in between. I always have a space between my measurement and my unit here, and for a distance, that's fine, and I will just go to normal text so everything looks good. Now for the center, I am going to use the average. I can use mean, mode, or median, but I'm going to use the mean. And to write it out, I'm just going to say the average or the center was calculated using average. And here's my sample calculation. Again, make sure you're not showing a sample calculation for all. You just want one sample calculation. If you show multiple ones, then it's no longer concise. And for this one, I'm just going to go ahead and use the equation editor. I like to center my equations, but you're free to do anything you want. But we'll check to see how everything looks like. And you usually go insert and you go to equations. Now I want to show you what doesn't work and what works. So I can write this as average is equal to, and then I can write the equation. So I can go ahead here and go to A by B, and I can write my values in. So I have 13.5 plus 12.2 plus 14.3 plus 11.2, and I'm dividing that all by 4. Now you can see that this looks pretty terrible actually. It's pretty small, it's really hard to read, and that's not what you want. So naturally you would go and click everything inside of the box, and you want to try to make this bigger. And you try doing that and it doesn't work. And that's because, well, Google has not fixed any of its problems yet, and for a very long time this has been an issue. So whenever you click anything inside of the box and you try changing the size, it actually doesn't work. What you have to do is you have to click the whole thing and then try changing the size, and then it will work. Alternatively, what you can do is before you make the box, make sure the size is slightly bigger, and then start changing things. And that way it will, again, it's stopped working. So I'm going to try selecting everything so it doesn't show the box anymore. And I'll just change everything to size 16, and I think that's pretty good. It looks pretty solid. Everybody can read it, and I'll move on from there. All right, my calculation here, this is going to equal to, I'm going to keep writing everything. We can see that size is now 16, and that's good. And obviously you can choose any different sizes that you want. It all depends on your work. And what I get is 12.8 here, and this is going to be 12.8 milliliters. So I'll write it out like that. And this is, I'm just going to put an equal sign, and I'm just going to move it a little bit so the equal signs are kind of aligned, and as long as they're pretty close, that's fine. Okay, now for the next one, I already calculated my average, and I'm showing how that center is calculated. Now I'm going to go back to normal text, and the spread was calculated using, and this one I'm just going to write the equation here, and this is kind of like the uncertainty as well, so I'll just use that idea, and I'll go down, I'll go insert equation, and oh, I forgot to change it to the proper size, so I'm going to go to 16 here. I'll go to center and I'll change it to insert equation. And I'm going to use, this is going to be my absolute uncertainty. And I'm going to use the following equation. I am going to use a division sign like this, and I'm going to take the max value subtracted by the min value and divided by 2. Many different ways of doing this. Some students, especially if you are in an IB program or a school that has already covered standard deviation, you can use standard deviation at this point. Sometimes you use, there's just so many different ways, but this is what I'm going to use for this particular example. Just use whatever your school recommends. And again, insert equation. This is going to equal to, I'm going to bring the fraction again, and my max value here is 14.3. My minimum between the four values is 11.2, and I'm dividing that by 2. I'm going to move this a little bit so it kind of aligns. Good enough. I'm going to go to the next line, insert. I'm going to go equation. This is going to equal to, and I believe this is, when I put this on my calculator, I get 1.55. And the unit here is also milliliters. Just adding them and dividing them. So that's what I get. Finally, I'm going to also show how I calculate percentage uncertainty. So I'm going to go to normal text. I'm going to say percentage uncertainty is calculated using, and here I'm going to go to insert equation. Oh, forgot to do this again. I'm going to go to size 16, insert equation, and percentage uncertainty is equal to, here is my fraction again, and I'll center it soon. This is absolute uncertainty divided by the average value, and I'm going to multiply it by 100%. So let me see if I can get there. Insert, multiply by 100%. And let's center this. Oh, that worked nicely. Okay, good. And insert equation equals to, my absolute uncertainty is 1.55. I don't have to write the units here. I'm dividing that by, oh, okay, let's try this again. I'll just write it as such. 1.55 divided by 12.8. And to move between these, I just use my right arrow key to go from one to the other. So if you're having trouble with that, you can do that. And I keep moving right now. I don't even see the cursor, but I think is in the right place. 100%. And again, I'm going to move this so that it's kind of aligned. And let's go to the next line, insert equations, and this is going to equal to, do this quickly on my calculator, and I will get about 12.109 ... because it just continues percentage. And I need to give an approximate percentage. I don't really need that many significant digits here, so I'm going to say insert equation, and the next line, insert equation. And I'll go for the approximation sign here instead of equal, and I'll just round it to 1 decimal place, or just no decimal places. So I'm looking for this approximation sign. I can't even, oh, there we go. And I'm going to say 12%. And leave some, oh, that's good. Good enough. And I'm going to have a therefore statement at the end. So I'll write that as an equation because I want the therefore sign if I find it. Okay, I don't see it. So instead, what I will do is I am going to go to normal text, and I'm going to go insert symbol or special character. I'm looking for a therefore sign, so I need 3 dots like this. So that's therefore, there we go. The volume for a distance of 60 plus or minus 2 centimeters is approximately, and for this one I don't really need to write the percentage. I'm just going to write it 12.8 plus or minus this value. Remember that your uncertainty always needs to be expressed in one significant digit. That would make this 2 milliliters. So I'll just write it like this. I'll change it to milliliters. The 1.55 actually rounds to 2, and that's one significant digits. That's good. And since this has no decimal place, now our number has to be rounded to something that doesn't have any decimal places, and 12.8 is just rounding to 13. So that's our value there. Now that I've shown my sample calculation, I'm all good here. I'm ready to move on to the next step, which is actually having a process data graph or table and then plotting it. So I'm just going to copy the distance part here using Control C and Control V. You can use Command if you want. And I'm calculating the average volume here. So I'm just going to say, and I don't need 2 cells anymore. I can just work with 1. So I'm going to do this, and I'm going to just shift this all the way down. And I'm going to go for average volume here. And I can actually do this in the side as well, but I'll just do it here. Average volume. And the unit that I need to work here with is milliliters. So I'll just write it like this. I'll make this a little bit bigger. And in order to find the average here, what I did is I just found the average of all these values. In order to do this on Google Spreadsheet, you're just going to press equal. And because we want to find average, we basically type in average. We open bracket. We select the values for which we want the average to. Close bracket, enter. And it says, do you want to autofill for the other values? We do. We just press OK. It's beautiful. We had gotten 12.8, so it's a good check. If you had gotten like if you had done the calculation for 20 and if you got it 81.5, sometimes it's hard to be sure about other ones. That's why I kind of like to choose something in the middle or at the end just to make sure all the calculations are correct. We also want the uncertainty here, and this is going to be measured in the units of plus or minus milliliters. So I'll just put that in and close it. And we also want the percentage uncertainty, and you can just leave it like this because it can only be in percentage. For the uncertainty, what we did is we took the max value, subtracted by the minimum value, and divided it by 2. So I'm going to go ahead and say equal. I'm going to open bracket because it's a division, and I need to make sure that my numerator is in proper brackets. And I'm choosing the max value between all of these 4. This is exactly what I did. For mine, I took 14.3 for this row. I'm going to close bracket. It's going to choose the maximum value there. I'm going to subtract it by the minimum value between these 4. And close brackets. And I'm going to divide all of that by 2. So basically, I get the max value minus the minimum value, all divided by 2. Very similar to what I did in my sample calculation. I'm going to autofill, and I get 1.55 as a check. It's all good. And for the percentage uncertainty, I basically took the absolute uncertainty, which was this value, divided it by the average volume here, and then I multiplied it by 100. And that gave me the following, and I got 12.1 or 12%. So it's all good. And now that I have all of this, I want to make it look good because at the moment they don't look that great. So I will basically take all of these and I will center them by doing this, and I will always do this as well. I'll do the same thing here. I just missed it. And I am going to bold. I am going to color these in. Let's do just the gray. And then I want to make sure that everything has proper borders. This is visible. You gotta show this for your process data. So I'm just gonna make this slightly bigger so it looks good. And for the data, we need them to be in proper number of significant digits. For percentage, usually just one decimal place or percentage is fine. So I'm gonna kind of change that to this. And it's just 5%, 14, 12, 15, and 31. These need to be to one significant digit, so I'm going to reduce them to one significant digit like this. And ours was 2, which makes sense, and our volumes need to match in terms of number of decimal places. So I'm going to go to this, and this is what it looks like. It's fantastic. Now Google Spreadsheet will use the exact value when it's plotting, and that's fine. That's what we want. And let's go for it. It's time to plot some data. All right, we want to plot our independent and dependent variables, and our independent variable here is distance, and our dependent is the volume that was collected. So I'm going to select these cells. I'm just going to do the numbers automatically. I think pick everything up. I'm going to go to Insert, and I'm going to go Charts. And automatically it goes to a chart like this, but as scientists, we usually don't use column charts. Instead, we use scatter plots. So I'm going to go down and select scatter plots, and you can see the data looks pretty nice. And now it is time to kind of customize everything. It automatically picked up that this is distance and this is volume, but we're going to make some changes. But before that, I'm going to get rid of the title here. We don't usually do the title up here. We usually just include a figure number and the description of the graph underneath in our report. So I will just delete that by clicking on it and deleting it. And for the rest of them, I will just go through the menu to show you. You can actually just select and get to a certain menu, but I'll just go through all the menus so you have an idea about how everything is working. First, I'll go to Customize, and I'm just going to go down first because I know that my vertical axis is starting from 0 to 100. It looks pretty good. For my x-axis, I also wanted to start at 0, so I will go to horizontal axis, and I will just go down, 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 and for the minimum value, I'm just going to start it from 0. And now it's looking good. For the max value, we'll go a little bit over 100, so it looks a little bit more solid. So 120 is fine. And that's good. That's all I want from this menu. Right now, I'm in the Customize setting on the right-hand side, by the way. Start with chart style, background color, it's good. Border color, what will happen if we change it to nothing? Oh, okay, it just gets rid of the border. I'll keep the border on. Actually, I'll just use gray. And okay, don't need anything else. This is fine. We're going to go to chart and axis titles. And we get a lot of different options up here. The chart title we already removed. We're not using subtitles. For horizontal axis here, that's the distance plus or minus 2. You can also just switch between these, and if you click on it, it will go there. This is pretty nicely done. And a distance plus or minus 2 centimeters is exactly what we want. Now, Google Spreadsheet does not allow us to do error bars or uncertainty bars in the x-axis, which is kind of sad. But we still have the option of putting the uncertainty in our title, which is pretty good. One other thing I wanted to mention is that if you need another unit which requires a subscript, such as centimeters squared or centimeter to the -2, for example, if you want to do area, then Google Spreadsheet also doesn't allow you to do that. So, but there is a workaround, and the workaround is here. And I will post this on the YouTube So you have the link to it, so you can always access it. But you can also just go to this website over here. It's a superscript generator, and just type in whatever you want. For example, if I want area in a unit of centimeters squared, I just write centimeter, and then I just basically take this and I just copy it, and I just go and paste. Right click and paste, and I have centimeters squared. So I'm going to delete that. I'm just go back here to the sheets, and I'm going to double click on the distance. So if I wanted this to be area, I could just paste that and I would have centimeters squared. It's beautiful. It actually works really nicely, the workaround. And I'll go back here. We don't actually want it to be squared. This is fine. I want things to be bolded. It looks a little bit nicer and sharper when it is. And I'm going to go to volume, or just switch from horizontal axis to vertical axis. I know that we're plotting the average volume, but we just want the volume because we're going to do the uncertainty bars in a second. And when we have the uncertainty bar, basically this dot over here does show the average and the uncertainty shows everything else. If we just write average volume, it kind of doesn't make sense. So you want volume, and we know the dots here or the points here show the average, and the uncertainty bars will show the spread. The center is here. This spread is using the uncertainty bars. And I want to bold this as well. Looks nice. We got volume, we got its unit. We don't have to say plus or minus anything here because the uncertainty is going to be shown using the uncertainty bars. Okay, good. Text, good. Font size is good. We can increase it. If you think that it looks better, bigger, then you will change it. And we're done. Here, we're going to go into series. This is where most of the stuff happens. Under series, this is volume, which is kind of what we're working on, so this is good. For the color, you can kind of keep it the same. I'll just change it to a nice purple. Good. And the size, you can keep it. I'm going to change it to 5, a little bit smaller. And the circles are fine. Nothing else really needs to be changed here. I'm just going to scroll down. Arrow bars is what I want here. Again, you can't do it in the x-axis yet. So for the x-axis, I have it as numbers. For the y-axis, though, or the vertical axis, I basically can put the values in. Now, Google Spreadsheet also doesn't allow us to have variable uncertainties for different values of our independent variables. And what I mean by that is if we go in here for distance of 20, our uncertainty of volume is 4. For 40 is 3. For 60, it is 2. And we can use a percentage, but even our percentages are not consistent. So we can't have a constant percentage or constant value for all of them. Microsoft Excel does allow us to do this, and it also allows us to do uncertainties in the x-axis, and I will have a separate tutorial for that because it's much stronger, really. But in this case, because we're not allowed to kind of show the variability, we do want to use a constant one. So we do want to show the absolute uncertainty and not the percentage here. And what I will do is I will choose the maximum value. Here our uncertainties are 4, 3, 2, 1, 1. Our maximum is 4, so I will just choose that value and I'll just put it in here. In your report, if you have different uncertainties and if you chose the maximum value, just write it down. So write down that the uncertainty are different for all of the independent variable values. However, because Google Spreadsheet does not allow us to show the uncertainties for the different values at this moment in time, I use the maximum value of 4, and that's fine. Okay, now that we have this, it looks beautiful. It's got the uncertainties for data table. Okay, that's fine. Now we need a trend line. So I'm going to click on the trend line, and we can see that the trend line is here. Color is fine. I'm going to change this from linear to other things very soon. Actually, I'll do it right now. No, actually, I'll do it in a second. I'm gonna move down. For the label, I do want our label to show the equation. When you go to equation, this is showing average volume. I don't like that, so I'm going to actually go to custom. That will allow us to kind of change this. I believe we can change the label here. I can just change it to volume instead. Can I? I think there's a way of doing this. I just don't remember how to do it. Okay. I'll just go use equation for now, and I'll see later if I can change that to something else. I'm going to go to show r squared value because I want that. I want the equation, so all of those are good. And you can see that the r squared value is 0.7, which is kind of like medium fit, and you can see that it's actually a very bad trend line. It only goes through one of the error bars, and that's not really a good thing. You want your line of best fit to go through most of your error bars. So I'm going to change the type. I'm going to change it from linear to exponential, and this is much better. It's going through 1, 2, 3, 4 of the error bars almost, and the r squared value has changed from 0.7 to 0.966, which is a strong correlation now. So that's much better. Let's change it to other things and just check. This is not as good. Still a strong correlation, but it's showing that our volume is going to start increasing at some point, and we know that based on the science, as distance increases, there is less light source, and that can't really happen. And I'm going to go to logarithmic. This is okay, but it's only going through one of the error bars. We go through power series, and this looks good. This is actually going through all of our error bars, and it's kind of going through the average pretty nice, and the correlation is also very strong. I'm not sure about this line over here and why it's there, but it's there. That's okay. And you can change the line thickness as well. Here too is good. This is looking pretty good and solid. And okay, we're good here. I'm gonna basically get rid of this. We have our r squared value, we have our equation, we have our trend line, we have our uncertainties. We're pretty much ready to move on. Let's just go to legend and see what that has. We can change these positions. So we can go from top, which is kind of auto right now, to other places. I like it here. This is fine. Horizontal axis, we've already checked this. We changed this to 0, 120. All of those are fine. You can also slant labels if you want at 30 degrees. I find that auto is fine. And good. This is fine. We'll look at grid line in a second as well. I just want to double click. Oh, we can change this. Okay, I'm just going to change this to volume. I'll just delete that. It looks much better. And can I actually just completely remove it? No. So I'll just go back and just change it to volume. It's better than, yeah, okay, good. And you can go to grid line and ticks as well. So for vertical axis steps, you can change how far these are from each other. Grid line color is auto. Sometimes I don't mind actually removing them. This looks nice and clean. And you can do the same thing with the horizontal axis. Basically go in and change the grid line color to white, and this looks really, really nice. Again, keeping it in is okay too, but this looks fantastic. All right, now we have a beautiful graph over here. It's got our y-axis label, x-axis label, and uncertainties. The graph itself shows the average and uncertainty bars. The line of best fit goes through all of the error bars. If it doesn't go through all of your error bars, it should go through most of them. The r squared value here is 0.995, which is really good, and the equation of the line is also given. Now it's time to just put this in the documents. We go here, we right click, we go copy charts, and we go to our documents, and in our document obviously we have to write a lot more stuff. Right click and we're going to paste it in. You can link or paste unlinked, it's up to you. I'm going to paste it like this. And we didn't have the title on top for a good purpose, because in most scientific documents we write the labeling here. So let's say this is figure 1 or figure 2, whatever figure number it is. And this is the relationship between the distance and distance of the kabomba plants and the light source and the amount of, and the volume of gas that was collected due to photosynthesis. And I'm gonna capitalize this, and here's how your graphs should look like in your reports. And the process again, if you found this to be a little bit fast, then you can always slow it down and kind of pause and see what you need. And if you found it to be too slow, then obviously you could have sped up through it. And I hope that this was a useful video for you, and I hope that you can now plot things using uncertainties with Google Spreadsheet. Have a wonderful, wonderful day.